All right, so now we're going to talk about Unit 2, computers and computing. So the objectives of this unit are to be able to describe a history of computing technologies, talk about the components that go inside of computers, describe the power of computers, be able to define the different types of computers that exist, explain how computers process information, and then define software and the different types of software. Okay. And I have, for the components portion, I actually have a small video that is posted that actually goes through a demonstration of the components of computers. So a history of computing technologies. The first generation came about in the 1940s, 1950s. And these were large, bulky rooms that took up the size of an entire room. And they were largely custom machines. And some examples are UNIVAC and ENIAC. Okay. These made use of these bulky vacuum tubes, which were prone to failures. In fact, the first quote unquote bug in a computer was literally a bug. It was a moth that was found to have interfered with a vacuum tube. And in the computer log, the person who discovered it, Grace Harper, who was a pioneer in the computing field, taped the actual moth to the log and said, quote unquote, bug. Okay. In the 1950s and 60s, we had a second generation. This is also when Silicon Valley up in the Bay Area really took off. So prior to that point, Silicon Valley was a sleepy farm community. And starting in the 50s and 60s, the semiconductor manufacturers started locating their facilities there to build computing devices. At the time, transistors had been invented, but computers were still quite bulky. Okay. IBM was the market leader at that point. IBM still exists today, by the way. Now, in the 1960s and 70s, we reached the third generation of computing. This is where the integrated circuit was invented. We had early network connectivity. IBM was still the market leader. But wait, something happened in the 1970s, 80s, and early 90s. We had the fourth generation. This is when the personal computer came about, and now anybody could have a computer on their desk. Okay. We also had mini computers in offices. This is also when portable storage media like optical or CD or DVD drives or floppy disks started coming about. This is also where we started seeing a split between IBM and IBM clones, and then the rise of Microsoft and Apple. Okay. The fifth generation occurred in the 1990s through the mid-2010s. This was the fifth generation where we had PC and Mac desktops, laptops, we had Sun, Dell, HP, and IBM servers, we had the rise of the internet, we had this new thing called USB, which miraculously let us plug in any type of device into one port on our computer, Bluetooth, which allowed us to wirelessly connect things to our computer, and then we had the rise of Windows and Mac OS as the two predominant operating systems for you and I to use. Okay. The sixth generation is starting in the mid-2010s to present. This is where we have graphic processor units or GPUs, which are being used for artificial intelligence. We have a proliferation of Internet of Things devices and smartphones, and we're just on the cusp of having quantum computing. Now, computer components, we have a central processing unit or CPU. This is what we refer to as the brain of the computer. This processes all instructions and performs operations, okay? Next, we have the random access memory or RAM. This is the short-term memory of the computer. This is where we temporarily store things until they're needed by the CPU. Now, when the power goes out, RAM loses its contents, okay? The motherboard. This is the board that contains circuits to connect the CPU, the RAM, our monitor, our keyboard, our mouse, etc. Okay. We have a disk drive. This is used for long-term storage of data. We have several different types. We can have magnetic, which is a hard drive, or in the past, a floppy drive, but nobody really uses floppy drives anymore. Optical drives, which use lasers, so CDs and DVDs. And then the third is the most common today, and it's also the most recent, it's solid state. This is where we've got memory chips effectively. So we have an SSD or a solid state drive, there's no moving parts inside, or a memory stick. We have input devices. This is how we input data into the computer. An example being a keyboard, okay, a mouse. An output device is a device used to output data from the computer. So a printer, we could have monitors considered an output device. And a pair of headphones is an output device. So power of computers. So there are three factors that describe the capabilities of a computer, and they are accuracy, storage capacity, and speed. But for most of us, only the last two are used, okay? Accuracy really applies more in scientific circles, okay, very high-end computers. We don't think about accuracy when we go to the store. So I don't go to the Apple store and think about, gosh, I want an accurate computer, right? I kind of assume that it's reasonably accurate for my purposes. But I do think about storage capacity and speed. And so storage capacity, when we're talking about RAM, we're still talking about gigabytes. Okay? When we talk about disks, however, whether they're a hard disk or a SSD, we talk about gigabytes, terabytes, and petabytes. Okay? Speed, we measure in different ways. So if we're talking about network and memory speed, we talk about measuring in number of instructions per fraction of a second. And so this could be in milliseconds, microseconds, nanoseconds, picoseconds, okay? CPU speed, on the other hand, is measured with gigahertz these days. It used to be measured in megahertz. Okay? In the future, it will probably be measured in terahertz. Input devices, so some examples: keyboard, a mouse, a touch screen, a tablet, a barcode reader, okay? You get the picture. Output devices, monitors, printers, audio, disk drives, etc. We can have different computers. So we can have laptops, which are portable, but they have limited expansion. We can have desktops, which are stationary, but they're expandable. We can have servers, which are used for enterprise applications and websites. And so servers, I'll take a brief moment to talk about servers. So servers, every single day, every single one of us, unless we're not connected to the internet, are using servers. I mean, we may not even realize it. Right now, you're streaming this video from either Yuja or YouTube. And guess what? That's sitting on a server. And there's a server serving it to you. Okay. Oh, you just checked your email. You use an email server to check your email. Oh, you just got on Facebook. Well, that's a web server and an application server that Facebook runs on, okay? The web runs on servers. Businesses run on servers. Mainframes, these are an older style computer. They still exist, but they're mainly used for large enterprise applications. And they're quite expensive. We have supercomputers, which are used for research. So the scientists trying to find a COVID vaccine are probably using supercomputers. In fact, UCR has a large supercomputer facility on the campus for research purposes. Then we have smartphones and tablets. These are portable handheld devices. So let's talk about software. Software runs on computer hardware, and we have different classifications. The first being system software, like Mac OS, Windows, Linux. And then application software, Google Chrome, Safari, Microsoft Office, Photoshop, that sort of thing. Okay. So system software, we also have firmware which sits on our machine. When we first boot up our machine, before it boots up the operating system, it boots up firmware. Okay. And then we have the operating systems. On mobile devices, we have iOS and Android. So application software, we have three major types. Desktop, this is things like Microsoft Office, QuickBooks, Microsoft Project, okay? Cloud-based software, Salesforce, Google Docs, Box, Dropbox, etc. And then servers. So we have server applications, database servers, application servers, and web servers, okay? And that's it for this unit.